All right. Okay, cool. Okay, everyone, if you can start to take your seats, I think we're about to get underway. For real this time. I'm just double checking that everything looks good on YouTube, but it should be good. Okay. All right, I think we're good. I think we're good to go. Sorry about that. I need to share my screen. Sorry, 1 minute. It's great content. Okay. Sorry about that, and sorry about the late start, everyone. Thanks for your patience, both people in the room and watching at home. We had to change the link on YouTube because we stuffed up the meeting. But anyway, we know for next time. So hopefully that. Okay, so to begin with, I'd like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to elders, both past and present. As always, a bit of housekeeping before we begin. I'm Zach, one of the organisers. We've also got Nikki, who helps me out with CocoaHeads. So feel free to come and say hello to us. But thanks to everyone for coming tonight. It's great to be back in person. And of course, a massive thank you to Bilue, our sponsor, because without them, tonight wouldn't happen. They've provided the space, they've provided the food, people in the room, and this great setup for all the live streaming. Highly technical, I just don't know how to use it. Should be better in future months, I hope. Of course, a reminder that CocoaHeads has a code of conduct. It's available on the website in full, but it boils down to a few key points. They are be respectful, be inclusive, and be aware. And this applies to meetups both in person and when we're doing things online. So in the Slack or any Zoom events we might hold as well. If you have any issues or concerns related to the code of conduct, please speak to Nikki or myself, and we'll do our best to help you. There's also the Slack community. I've just been talking to a few people in the Slack community before we began. People watching at home, following along in there. So feel free to join both while we're here on the night, but also throughout the month. It's a good place to keep up with other iOS devs and ask some questions and have a bit of a chat. Haven't got to do this in person for a while. Are there any first-time attendees in the room tonight? Hand up. Woo, welcome. Yeah. Big welcome. Thank you for coming out. We don't always start that late, just FYI. Do our best to be on time. And of course, a shout out to Melbourne CocoaHeads. So if you like what you see here tonight, Melbourne CocoaHeads do a very similar thing every month. They're on the second Thursday of the month. They're in Melbourne, but they also have a great live streaming setup. And so it's very easy to watch their meetups online. They do a similar thing on YouTube. Definitely recommend checking them out if you enjoy tonight. So a bit about tonight's schedule. It's the fullest it's looked in a while. It's very exciting. So we have a bit of an intro from Bilue. And following that, we have a first talk from Sam. We'll get into a quick hiring firing if anyone's looking for work or is hiring. And we'll also take a short break. It's an opportunity to grab some pizza or another drink if you like. And then we'll get into our second and third talk. So our second talk from Terry and our third talk from Balazs. So looking ahead, what do we have to look forward to in the upcoming months? Next month should be awesome, where we're going to be in person, but most of our speakers, my understanding, are going to be remote. So it's going to be an interesting technical challenge, but I'm sure we'll be able to pull it off. So to celebrate the Global Accessibility Awareness Day, which I believe occurs in May, Aaron Stevenson, who some of you might know, is having given some really great accessibility talks over the years. He's organised sort of a panel of speakers. Last I checked, there were 3 to talk about accessibility related things for the month. So that's going to be awesome. And the other thing we have to look forward to, so of course, June, WWDC month, we're going to be doing something a little bit different in June to our regular months, and that's something we've done for a few years now. So we're going to have a panel discussion on WWDC, talk about some of the exciting announcements. I think the meetup's either a week or 2 after WWDC, but we're also going to be having a charity auction. So we've been given some old Apple memorabilia, which can be yours in exchange for a donation to a charity, the Lifehouse charity we're raising funds for. So the gear's been given sort of on the condition that it goes with a donation to Lifehouse. So that's something to look forward to. And if any of those interest you, definitely something to look forward to in June. The shirt is a medium size, if anyone was wondering that, and like a men's medium. And the jumper, it said that it was kind of a universal size, but it's pretty similar to the shirt. So probably also a men's medium. So on that note, what's been happening, we have WWDC to look forward to. It's probably the most exciting thing that's happened in the Apple developer space over the last month. So it's happening online, again, something to look forward to. But there's also this mystery in-person component, which has been mentioned on the website, but no one's really gone into much detail, but supposedly for devs and students to do something in person on the first day of the conference. I'm sure we'll know more over the next few weeks. And I did just think it was worth calling out the Swift Student Challenge, which is happening again this year. It's an opportunity to apply for a scholarship ticket to WWDC. For anyone who's eligible, I think you have to be studying. It's a great opportunity. I've done it myself, and I highly recommend that to anyone who's sort of interested in potentially attending WWDC as a student, even if it is virtual. It's still an opportunity to build an interesting project and sort of work through an application process and applying to submit that to Apple and potentially getting some feedback. So that's pretty cool, as well as, of course, you might get some cool WWDC perks and things depending on how Apple chooses to do things. So on that note, that's all I've got for tonight. Again, thank you for coming. Great to be back in person. And I'm going to hand over to Sam for the first talk. Yeah. So, okay. To present and this one, it's a little bit complicated. And do. Yes. Screen. So you put your notes on this screen, and you just click on that from what you need to do. So, part of it. Yeah, cool.
Cool. Hi everyone. My name is Sam Jarman. I'm a software developer at CocoaHeads. I am a bit of an imposter tonight. I no longer do iOS development. I did, however, get excited seeing the words view controller here. So there's something still down deep in me. I just can't shake it. But it's got nothing to do with UI view controller. My first love, maybe. I don't know. Tonight I want to talk about solving problems and problem solving. It's something I've been really mulling over lately in my career about, like, okay, this skill is obviously really important, but how do we actually get better at it in a very explicit and deliberate way? So I've got a bunch of tips in 26 slides tonight to sort of talk about some of the things that's rattling around in my head about it, hopefully it helps you. If you're been a developer for a long time in the room, I hope you're just like, oh yeah, that's right. If you're more junior in the room, I want to get across the fact that this is a skill that builds up over time, and there's really no substitute for just code out the door and experience for the stuff. But it is a skill you will learn if you apply and reflect on it. And even though some of the seniors you see in your day-to-day work might seem like wizards or magicians or just like you'll never be that fast, I promise you will if you follow my tips. Let's get into it. First of all, we all have been in that situation where it's not working and the deadline is coming, and as the geniuses we are, we've somehow called our work sprints, which is a stupid idea because there's nothing sprinty about it. It's a bit of a fast walk, if anything. And so we put all this pressure on ourselves for like deadlines and like artificial deadlines with Scrum to get something done. And that's weighing in your mind and you're like, just starting to freak out. It's coming up to 5 p.m. or the sprint is closing tomorrow, or like you've given an estimate that you can't hold up and you're rushing. You're essentially just rushing. And it's a trap that we all fall into to get into this rushing mindset. It's a terrible, terrible place to be for having your brain to work at its optimal fashion. So the first tip is just to stay calm and collected, because you won't be able to like think properly if your brain is busy worrying about things that aren't the problem at hand. Now, like a story time, like when I was a junior, I remember being in like a backlog grooming session or like a sprint planning session, and a task was coming up, and like my name got put on the task, and I just started freaking out because I had no idea how to do the task, and I didn't know every line of code I needed to write to do the task, and that just really panicked me. I'm like, I can't do that. I don't know how to do that. And I talked to one of my seniors, and he was like, I've got no idea how to do tasks at the start of a sprint, like or at the start of the unit of work. I'm like, well, what do you mean? He's like, I'll just figure it out. I'm like, I'll never be that good. And now, when my graduates come to me on my team, I'm the tech lead on my team. I'm like, I've got no idea. Let's figure it out. And we just hop on a call and just start figuring it out. And so I think, over that 10 years development that I've been doing, you start to just get more confident in those skills. And by staying calm in the face of an unknown, you're actually able to like start to tackle it and just not panic about it, which is super important. Like it's a problem. It's not a knife. It's not a gun coming at you. It's just a problem. And, all right, let's get started. So once you do get started, working logically is hugely, hugely important. Everything in technology and most of the world is a system. It can be a good system. It can be an absolute bonkers system. But probably a lot of us work in systems we consider absolutely nuts. But code bases are typically systems that have a design to them, maybe not a good design. And typically code is related, like organized in components or classes or methods or microservices or jobs or handlers or some unit. And these units is how we want to start reasoning about what's happening where. Most units have inputs and they have outputs. So if you know your unit and you know its inputs and its outputs, you can start to think, well, is the input correct? Is the output correct? And then you can start to follow that chain and start working methodically. So let's say you have like a typical iOS app. You might start going from left to right. You might read from the API, organize it into a model, organize that model, maybe like searching it or sorting it, then organize that into a view model, and then render that view model into your display. Does that sound familiar to the room? Cool. So like, if you see a bug there that's related to the price of an item, you might want to start following through the cost. The cost comes down from the server in a unit of cents, but on the screen it says it's $1,299. Something in that chain has gone wrong, right? So we look more carefully, and it pops out that this part has misinterpreted, this conversion from model to view model has misinterpreted the unit of this piece of data, right? It's taken cents and thought it was dollars and gone to dollars. So, you're able to rule out the API. The API is giving you back the right price. You know the screen's wrong. You know that the model is correct. So you roll out the model, you realize after searching and sorting, the data hasn't changed. So it must be the view model, right? Or the thing that you got in the view model was wrong, and like your UI label is working fine, but it's that last bit. So you're able to work methodically through your system to figure out what is going on. What the trap that more junior developers fall into is they work a lot in this area. So they check there first because that's their baby, that's what they know. And then they go to the UI because they know UIKit really well and Swift UI, and they know, they kind of stick to their favorites and they go, hopefully it's in a place that I have been before or I understand. That would be really helpful, pretty handy. But then they don't actually go into the code that they've been less familiar with. And that bias goes against the acting logical, and that what should be your intuition to act logically. That bias ruins that, and it ruins your investigation effort. And you'll get faster at this in the system that you work, whether it's the same code base day in and day out. As you get to understand more and more units, you'll be able to roll out areas quicker. There's no doubt that, you know, if you're new to a code base, finding a bug is really hard. It takes a long time. But if you're familiar with the code base, you can probably see the bug and go, yeah, that'll be that class or that portion or that component. The corollary to this is if you want to learn your code base really well, say if you're new to the code base, new to the company, take a bug off the backlog and go solve it. And that will give you a lovely tour of the code base. And then you'll be quite effective at solving future bugs or adding features. So yeah, don't panic about feeling unfamiliar in a new code base. It does get easier over time. And you know, you have the ability to ask for help from people who are more familiar with the code base and certainly point you in the right direction. Speaking of being pointed in the right direction, this has been a huge one for me. Generate clues. It's been a huge mindset one for me. And I often get stuck, as we all do. And there's nothing more I can do. I'm like, well, it's not this. I figured out the 10 things it's not, and I can't see a way forward. So over the last few years, I've been like, okay, what can I do to generate myself a clue? Now, we've all got some tools in our toolbox for generating clues, like a log statement or a breakpoint, or turning a view red to figure out if you've set the frame or view or view incorrectly. What's the other one? That's frame and the bounds. Bounds, yeah. Still got it. And you know, we've all got these tools in our toolbox, and so like the big statement there is like not all actions whilst troubleshooting have to be the solution. You know, not every action you take has to, in your mind, get you to the end step. It has not have to be the solution. It can be, well, I just need a new clue. I just want to try something. I just want to poke at it. I want to prod it. I want to take this like an exploratory approach to what I can see, and then hopefully it gives me like an aha moment and I see something new and I might think of a new clue. And so like by way of example, we've got private NPM packages at Cochlear, and a colleague of mine, which is kind of like a private CocoaPod, was having trouble installing one of the private packages. And so we ran like NPM install, which is kind of like pod install, basically analogous, and it was failing. And the output wasn't very helpful. We did know that there was a git clone as part of that process. So we tried to just manually, so like at that point we were like, okay, pod install doesn't work. As far as I know, my computer's set up properly with all the right permissions and stuff to access the private network. The log was no help. So the clue that we wanted to generate was, let's try run the sub steps that we know is happening under the hood. And so we ran a git clone over SSH, and then that's when the SSH dialog popped up saying, what's the passphrase? That was something that npm install was actually hiding from us. We're like, oh, a clue, SSH passphrase isn't set up properly. So we set that up, npm install worked. So the action by running, you know, trying to clone the private package was not going to be the solution, but it was a step towards the solution. It was an exploratory step, and it was hugely powerful. Over time, as a developer, you'll build up this clue toolbox. And I don't really want to list it toolbox of stuff. But I mentioned, turning views red and log statements and breakpoints and things like that, failing unit tests, inspecting network traffic, Charles proxy, all that sort of stuff could be in your toolbox as an iOS developer. But yours is probably already on its way to being well-formed, if not well-formed. And I think everyone's in their head. If you think of it as your clue generating toolbox, I imagine most people in this room can start to think of stuff that will be in their toolbox. Knowing your tools is hugely important. We say know your tools as being a developer. We've been and people think oh, that means Swift 5 or a bit of JavaScript. But this is another type of tool to learn, is how to actually debug the stuff you've got, and how to just basically give yourself more clues. If you do this over time, you'll be hugely more effective. If you understand and kind of reflect and think about very deliberately what you can do to generate clues in the code base you're in. The next thing is acknowledge progress. In the heat of the moment, you might do something and the error changes from error number 1 to error number 2. And there's this old phrase, which is a new error is progress. And this is hugely important because when you're stuck, your brain and mind and mental health can start to take a decline. I get frustrated. I get annoyed. It's kind of part of the fun, the rush of it all. But you see something change and you think, well, it's worse now. It's still not solved. Why is that happening? Why is it happening? The thing is, this is how you think it should work, right? You have a problem, you do something, then you have no problems. But the reality is most solutions, or certainly a lot that I've come across, you kind of have multiple problems on the way to being solved. And I guess the wisdom and the experience makes sure that you're going from 2 to 3 and not back to 2 or back to 0, going in circles. So this thing of realizing that something different is good. Oh, don't lean. Okay, sorry. Everyone's freaking out. That would be a problem. Solve that. No, all good. What was I saying here? Yeah, really fun.
That's a problem too.
That is a problem too. So yeah, knowing that, seeing a new era, you're cool, the state has changed, the game has changed, the input to my brain and the situation has changed. So what does that mean? And that could be a clue as well. So yeah, it's really a battle with your self-esteem. It's I'm never going to figure this out, because you see a new era. It's well, no, actually, that's something. And you get frustrated, you get embarrassed, and you start to feel incompetent, you start to feel like an imposter. Working on controlling those feelings is super important. Working on disciplining your mind and controlling your emotions, to quote Snape, is super important, because it's about your mindset and whether or not you can actually tackle this stuff. Problem solving is the crux of being a software developer. If you're not working on not feeling upset about having problems, you're gonna have a real shit time for your career. And this is something that doesn't necessarily go away. I still feel frustrated. I still feel annoyed at problems. Even this morning, I was swearing at something because I'm this shouldn't work. I went into clue generation mode and figured it out. But the point of it is if you have that low, you can have that high when it's solved, which is really nice, but also work on not making that low too low. The next thing is to survey solutions. And this is about keeping awareness about what is happening in the industry, what is happening in the framework or tools you're using. I've been playing a lot of Age of Empires lately, and I've got a really difficult metaphor to try to pull off here. Exploring the world of iOS development is kind of like exploring the start of the map during a game of Age of Empires. You have the stuff in black that you haven't been to yet. You have stuff in grey that you've been to, but you've walked away from. And if I was to put my knowledge, a subset of it, on this, I've been to Swift and Objective-C, Ruby on Rails, Django. I've now, it's kind of fogged over for me and it's sort of foggy. I've got stuff that's kind of in between the fog and the black. I kind of learn and unlearn if I need to use it. I've got stuff that I know exists, but I haven't got to it yet. Stuff that and then things over here that I'm oh, I know they exist, but also I haven't got to it yet. Knowing it exists, but not having got to it yet is a very, very, very good state to be in. Because on the outside of this, you've got all this red, which is stuff that you don't know about. It's the unknown unknowns. And that could be dozens of stuff, heaps of stuff, different languages, different frameworks. And if they're not within your map of what could be used in a situation, that could be my solution to my problem, that's a really hard place to be in. Like if you don't know that a UI collection view exists and you want to make like a square cell, you're gonna have a really hard time like fighting UITableView to do it. And you're going to end up with some really weird code, and the next person comes along and going to be like, why do they do it this way? Do they not know about this? I can take this 50 lines of code and make it two. And we've all been in code bases where you know something that the previous author didn't. You're like, why is it like that? And you're like, that's simpler. And so removing this red and moving it into the black is really good. And I like to do this by, so like, I call it adding solutions to your toolbox. I like to do it by like newsletters. Like there's a bunch of iOS weekly newsletters that are out there you should subscribe to. It's just knowing about and reading the first few sentences of each thing. You don't need to spend all day on Hacker News and Reddit and Twitter. Like these people have done the work for you. They'll just email you the 5 things you should learn that week, and just add it to your toolbox of potential ideas. Like a really easy example is like, I want to make a chat app and I want people to upload photos. So I need a thing that lets people crop a photo to a circle, to just put your face in a nice circle. And one of the Australian developers, Tim Oliver, Tim Tom Oliver, I don't even know anymore. He made like a cropping view controller that you put a UI image into and you get a circle UI image back. And you're like, oh, that's good to know that exists. That's something off the shelf. That's particularly good in the world of CocoaPods and Swift packages, where you're like, is there something I can just grab to do this hard thing? I don't need to write the unit tests, and I can assume it works and stuff like that. Super important in most ecosystems that have packages and vended code, but also just like database technologies, clouds, features inside of clouds, things that you might think, well, I need to build that myself, and you realize there's something you can just buy or pull in to do it. It would save you a whole lot of time and go back to working on the thing that your customers actually want. So keep adding solutions to your toolbox, and as you're stuck, you can think of these potential problems. It's not really about coming up with a mapping of like solution and problem, because that's not really engineering, right? That's like learning nail hammer. It's more like when you come across a unique problem, you have this toolbox of potential solutions. And so your colleagues, by the way, talk to them. And then you can apply one or look in to see if it's the right fit. Hopefully that makes sense. Lastly, ask for help. There's not someone that knows more than you, but knows more of the thing you're doing, usually. Unless you're like Chris Lattner writing Swift for the first time, chances are someone knows this thing as well, either on the internet or in your team, or in your guild or chapter. There's going to be times where you can't use any of the advice I've given tonight. You're so new to the framework, you're so new to the language, you're so new to the code base. You can't work logically through it. You can't generate clues. You don't know how to write a log statement in Elixir. You just can't do any of these things. You're like, you've ultimately set up for failure by being put on such a task. But at the same time, that is the perfect time to ask for help and like resign the fact that really the only way to get a clue is to say, hey, colleague, can you point me in the right direction for figuring out this thing? And they'll go, yep, sure. And they'll give you a list of clues to go follow and a way to approach the problem. You can then start learning, and it'll just open doors, and you should be able to get some good momentum there. In summary, I've lost a slide. Going backwards, ask for help, generate clues, work on that toolbox of potential solutions that are out there. Keep an eye on the ecosystem. Slow down, control your emotions, and ultimately keep reflecting on this skill set and keep working on it. There's no substitution for experience when it comes to this thing. I feel rude saying it, but working at a company that ships one feature every quarter versus working at a company that ships one feature every week, the person shipping a feature every week is going to get better at this faster, because there's simply just been more problems and more things to solve that are code related, not necessarily interpersonal or political related, but code related. there's no substitution for that. So keep working on it, keep reflecting on it. And if you're new to the industry or new to coding or new to iOS, and you're thinking there's no way I'm going to be productive in this, I promise you there is. Just keep at it. That's me. I'm on Twitter. That's my website and my email address. Thank you very much.
Does anyone have any questions?
Yes.
So I'd like to ask about the opposite of the talk that you just was really good, by the way, especially the Age of Empires reference.
Yes.
A+. So there are situations where you're working on a problem and you're the only person in the team, okay? Because you're working on a TV app, right? Or a watch app, and nobody's gonna help you with that. Or you're exploring new framework like Swift UI, right? And there are times when you cannot go to Stack Overflow and find any help, right? So my question is, when do you know that you exhausted all those ways to figure out how to solve a problem and just give up and say, okay, I can do that. I need to find another way, right? Because like, for instance, I was working on Swift UI screen, and at some point I just realized it's impossible to make it in Swift UI, so I need to rewrite it in the collection view. So the question is, when do you know that it's time to just give up? Because you also said that it's some sort of like an ego fight, right? Because everyone's probably have some sort of like some engineering mind, and they're trying to solve problem no matter what, right? But your time is valuable. So so my question is, but it's time to just give up and go on.
Yeah, it's a good question. It's a very good question. I think what's interesting is that when you introduced the question, you said like you're working alone, right? Or like independently on a project, or you've got no colleagues, perhaps you're contracting, or your current colleagues are not particularly helpful in a situation either deliberately or accidentally. I was in a company like that where I felt like I was working alone a lot. This is where I kind of started thinking about this stuff. It was probably my first time I really had to think how to work independently. This is where the majority of this talk came from, is the skills I developed over that 18 months in that not particularly pleasant environment of the business needs this, build it. When is it time to give up? Well, it depends on whether or not, like, why you're doing it. Like, the user probably doesn't care if it's Swift UI or UIKit. Your manager probably won't, your customer won't, But if it's a brand new feature that your customer wants, we need to figure it out regardless, right? So there's things we can't give up on because our customer needs it, our business needs it, the market is demanding it of us. And then there's things like arbitrary technical choices, which is like, well, this package isn't going to do it, this framework isn't going to do it, I can just change my approach, or I can't figure out how to do it with this new tool fast enough, I don't feel productive. That's completely valid, like how productive you are with a certain tool is a reasonable way to evaluate that tool, even if it's not technically better, because you've got all sorts of constraints. I was listening to a podcast this morning about architecture, and one of the things that caught my attention was, architecture is not just about best practice, it's best practice in context. And the context was, you need to build a screen. It's not necessarily I need to use Swift UI, which could have been best practice at the time. It's not really best practice if you can't get the job done. I feel like I'm dancing on the question because I don't have a great answer for you. I'm just generating clues on my own.
Yeah, it's very
it is a
specific
tough question. Yeah. And in my experience, there has been times where I've taken days and days and days to try to figure something out and no one's going to help me. And it was just, anything I could find to help me on my way. Open source, Stack Overflow answers. If I knew it could be done, that's when I felt particularly motivated, because I'm like, surely, like I know this has been solved before, how did they do it? And sometimes those people are nice enough to open source their code, and sometimes they don't. So I've like reverse engineered other people's apps before, other people's frameworks they've been shipping, and had a chat with their developers without their permission by looking at their code to sort of figure it out. But yeah, there will be a time where you're like, hey, actually, it's in my best interest as a developer to serve my person who's paying the business, right? And it's my professional opinion that I need to stop this approach and go down an approach I know then I can trust like not using Swift UI full time yet. I don't think that's a failure because I've delivered what I'm there to do, which is build an asset for the company, for the company's customer or client. It does crush your ego a little bit though. I'll give you that one. But yeah, does that help or make sense?
Yeah, totally. Thank you.
Okay, cool.
Any other questions? No, well, Sam will be around.
Yeah, I'll be around.
Awesome. Thanks, Sam. Another round of applause. We're going to take a super quick break, so quick that I'm not even going to mute anything. I don't want to touch the setup. So if you need to run to the bathroom, get some food or get a drink, go for it. We'll be back in about 2 minutes. Yeah.
Change it from .com.
Yeah, man. Sometimes you just got to time box it, right?
Same as before. The way it plays it.
Probably.
Like the way I frame it sometimes is, the goal is to deliver value to somebody, not to like get started. Yeah, so it's like how much value, like how many hours should I spend on this potential option? Because that's premium. It's definitely too much by then. I don't know. So I also work everything that's learned.
No, by all means.
How can I solve this problem? Because I'm working on the first of that. I'm very
Attention,
really
online
find any
speech recognition.
Attention, online speech recognition.
And there is the biggest problem. Like I wanted to like follow up. I can answer that one.
Okay.
You want to, if you can reduce it to something simple and demonstrate sometimes being there as an engineer on the other side is eventually going to get
Sorry.
somebody on the other side.
Yes, I am here.
I've spent hours and they're changing one line of code.
Time is 7:40 p.m.
Right, thanks everyone. You can start taking your seats.
Oh, yes, sorry.
Just curious, what's the problem that you cannot do in Swift UI?
And now we have Terry, semantic transcript. Oh, BSD, sorry, that was last time. Over to you, Terry, yeah.
Give me a reminder in 20 minutes.
Confirm setting reminder for 20 hours, 2 minutes, and 2 seconds.
I'm supposed to give a talk in 20 minutes, which will actually be half a talk. So the full talk would probably be 35 minutes. What are my reminders? Thank you. That'll just remind me. So, welcome to the originway.com presentation on BSP. So this is a design talk. It's about design models, and BSP stands for Behaviour, Service, and Presentation. If you think of MVC, it's a model like MVC, but it tries to address the whole pack.
whereas MVC is a partial one. So I want you to take some time to think about how much consideration you give to design. And I want you to think about what type of design constructs and tools you actually do use. And I want to differentiate it between different types of design systems. So I want to differentiate between a whole design system, and BSP is a whole design. So it addresses not only the whole app, but also the processes that go in to develop the apps, as opposed to, say, a partial design system. So that would be, for example, using localized design models that sort of patch together. So if you use the design patterns and various amounts of them in various places, and then you use MVC, that'd be a patched system. So BSP is a whole design process, a whole design model. So in this talk, there was going to be some theory and practice, but this is half the talk. So I'm going to be throwing a lot of ideas at you. And at the end, I'll probably just leave you hanging there. But the ideas are important. So BSP is also a methodology, as well as a design model system. And it tries to address the whole app. So herein lies your problem and the problem. And the problem majorly is complexity. And that's in complexity in every step of software development. Complexity in things you need to handle. And complexity is increasing every year. Every year from year to year, you have to build something that's got more capability, that's got more complex behavior, more complex UI. It has to handle more online services, more on-device services. It has to organize all that so it has more package dependencies, more greater, more fine-grained project hierarchies, and there's more subsystems and modules in every app that you build. So it's not like a stamping system where you just build up the same thing and the next and next. It's actually, it's on an incremental increase, getting to points where it becomes unmanageable. So BSP is about managing complexity, but not only the behavior, but what you provision for, how you manage those processes and so forth. So this is what BSP tries to do. It tries to form some form of cycle. So that's a cycle, sorry, that's a cycle. That's a cycle from design, incremental design, to implementing that incremental change. It may be a refinement, it may be addition, which then goes into the testing cycle. And when I say implementation, I mean testing as well, testing framework, going through a testing cycle and then going back to a design cycle. So it's incremental. And in order to do that, the system needs to do a number of things. It needs to form some form of representation for behavior. It needs to organize that behavior. And at the moment, behavior is just this amorphous blob, and we're going to give some structure to it. We need to decompose more of the complex high-level behavior into simpler parts. Yeah, and this is a fundamental idea of nature, that you find biological systems that do quite complex things, but what is actually happening there is a set of simpler sub-processes all interacting together to form something that's has got very complex behavior. So that's a similar idea for BSP in terms of the deconstruction and decomposition. There needs to be some form of collaboration in design. So design isn't just for the person who does the design. It's not just for the developers. It can be for the testers as well. Everyone can give input. One of the ideas from the Pixar company that builds the animations is that everyone in the company actually can contribute ideas. So you've got a greater pool. So maybe marketing can put ideas into, you may not want that, but marketing could introduce some ideas into the collaborative design process. It needs to be incremental design, and really importantly, the design that gets produced needs to be testable. It needs to be inherently testable so that you don't have to play around with it to make it testable. It's naturally in itself testable. And all this structure provides contours and boundaries from all that. It was an amorphous blob, so that you get an idea of where things fit, you can separate things, and you can start to work out work items and team assignments from that abstract structure. Okay. So this is again what it tries to do. BSP tries to give you a set of design capabilities, and these capabilities are in a ring, and it tries to give you a set of design constructs, and those constructs support the capabilities. So incremental design synthesis, that is supported through behavior representation. We're going to represent behavior, but high-level behavior as interactions. Collaborative design is supported by making those designs visualizable. They can be shared, they can be collaborated, and it's something that people understand. It organizes the behavior. And so there's categorization of behavior into levels. We'll talk about those levels. There's decomposition, again, of higher order behavior into simpler processes and parts. And it gives you a sense of when you have like a quantum of behavior or a workflow, it gives you an idea where it fits in the whole design. It's going to have things that engage that behavior and things that behavior engages, and that activity of engagement and output gives you a sense of where this quantum of behavior fits in the whole thing. And it needs to be testable. And we use notifiers, which I'll explain what those are in the next few slides, so that it decouples everything, forms pathways of engagement, so that it's naturally engageable and testable because of that. You can engage it and you can observe it, what happens. So, first section in theory is behavior representation. So, we're going to represent behavior as interactions. And there's workflows being done in what's called actors. And the interactions are notifications that are emitted and collected by the actors from source to target through a standardized pathway called a notifier. So that's going to represent interaction. So the actor can receive, and it can emit notifications. So it has inputs and outputs. The notifier defines a notification pathway. And there's two types of notifiers. There's a request notifier when you want to engage a workflow for an actor. So you give it a request and you notify a request of this type with this parameters. And there can be, you have an event notifier when that actor observes something intrinsic in itself and it needs to indicate outward. It doesn't know how to handle that event, but it needs to indicate outward to do something. And each notifier has a data type associated with it, which represents the request. It could be an enum, indicating the request, or the event that it's observed. So I'm talking about really abstract stuff, and this is where you're probably going to be left hanging in the end, because I can't give you the practicals of the code and stuff that does that. Well, there is a demonstration app which is available. I'll talk about that later, which you can actually see a running system. So this is the design principle. Behavior represented as interaction, modeled as actors and notifiers, and in turn that fabric that connective fabric that they define forms an interactional topology with some form of structure, and that structure then gives that amorphous behavior blob that you had before some meaning, some relationships, some structure, some parts to it. So this is the basic interactional model for the BSP. So again, there are actors. So there is the service actor, the presentation actor, and the behavior actor. Each have separate roles. The service actor performs OS services. So it has a notifier, a request notifier, which engage and tell it to do some form of OS operation, get the location, do some comms, get some data from an underlying database, those type of OS services. So it has a request and an event. An example of an event for a service would be, say, authorization failure. You wanted to check for authorization to use the microphone. That failed, and that gets submitted by the service sector to say, I've got this thing I don't know what to do with. That actually goes to the behavior actor, and then it decides what to do. So similarly, there's a presentation actor, which handles the UI. Similarly, it has a request and event. And then these two side ones are actually thin clients, thin actors with very short call chains. But the behavior actor is the fat system that actually does stuff and actually decides what to do. It coordinates and orchestrates and so forth. This ends up being naturally testable because first things are coupled through those notifiers. So you could actually test the service actor by itself. You can engage it and you can monitor what it does. Similarly with presentation, it is decoupled and it can be engaged and observed. And these notifiers represent activity. So if I differentiate between workflow and the actors are performing workflow, the notifiers indicate activity within the system as opposed to workflow. So you can monitor and engage it to do things through its activity, and you're engaging workflow. So some definitions. So I'll give some formal definitions. So the behavior actor, it imbues the unique application behavior of the system. So that it includes a traditional business logic, but it goes far beyond that because it includes the whole behavioral state. So anything that's unique that needs to be decided, that is not about getting something from the OS or getting the presentation to do something, is encapsulated in the behavior actor, and it's about behavior, the behavior of the app. In terms of concepts, behavior actor tends to deal in abstract high-level application concepts, as opposed to the presentation actor, going back, which would deal in hosted UI concepts, and service would deal in hosted OS concepts. So I'll term those concepts as a material concept. So presentation and service deal in material concepts that are already there. They're given to you by the OS or the language. And behavior tends to think in terms and express in terms of more abstract things, to organize, to coordinate, to orchestrate it. Okay. In terms of workflow, behavior will orchestrate and coordinate, so it's doing high-level type of operations, whereas presentation will tend to control directly UI elements and graphical elements, and the service will control OS services and ask them to do very basic OS things. And this encapsulates MVC, so you may notice that the presentation actor actually includes and encompasses the view models. So again, coordination in terms of workflow, there's coordination and orchestration. Coordination is a fixed workflow step and you just sequence through those steps. And orchestration is where you have to synthesize the actual workflow. And maybe as an example, think of an app that sends emails and text messages out, and you give it the actual content, and it needs to go through the content, do some heuristics, and decide who gets that email and what method they get it. So that workflow has to be orchestrated into the fixed steps of sending an email or a text message, and that has to be orchestrated and constructed. Okay. So here's an example. It's another interaction diagram example of a simple action where you have an app with a button, and it's supposed to, when you click on the button, it gives you the location. So this is the sequence that would happen. So in the presentation actor, there'd be the view model for that. There'd be a button handler for that. It would fire, it would observe the event, and then it would issue event off to its presentation event notifier. But it won't issue an event saying button 2 got clicked. It'll issue an event that represents the intent of that. And the intent is to show the location. So it'll issue an event saying, I got requested to show the location. That goes to the behavior handler, the behavior actor. So it's the core authority of deciding what to do. And it will form a coordination role, a coordination work role. First, it sends off to the service. It issues a request to services to get the location. Services replies back. And then in the behavior workflow, it then tells the presentation system, it issues a request for it to present that. So there's a little more chatter. There's a lot more chatter there, but BSP is for complex systems, for complex organization. And if you had a simple app, you could encapsulate all that decision logic really into the presentation system and just do it there. But when you get complex systems, you start to need to separate roles out. Behavior organization. So BSP tries to break down behavior into 3 levels: macro behavior, mid-level behavior, and micro behavior. Macro behavior, again, tries to do abstract, more wide-ranging roles. It tends to do more abstract orchestration and coordination. And it takes on a more open-ended type of roles. As opposed, say, micro behavior, which is for OS and UI, it has more fine detailed, more well-defined and straightforward work that it needs to do. It's just been given a request to do something and it does that. And micro behavior addresses and only uses material concepts that already exist around. It doesn't have to create new concepts. And mid behavior tends to be a strata or a composite of those, migrating from macro level type of characteristics to micro. So in BSP, once we have recognized those characteristics, we assign a design model that's appropriate for that behavior level. So macro behavior is assigned an interactional design model. Micro behavior, which does a lot of work. It does a lot of fine-grained work that's very straightforward. We give it I will say that it's more instructional. You give it a traditional subsystem. And then the mid-level is possibly a number of strata migrating from interactional to straightforward subsystems. So decomposition. BSP tries to decompose things and it recognizes a lot of high-level behavior as what is called scopes or behavior scopes. So they have indicative of, they have a number of phases. They have an initiation phase, termination phase, and an operational phase where they may have a number of sub-operations. And you've all worked with these before. Here are some examples. The application scope cycle. So in the application scope, you construct the resources for the app. You finalize or terminate with the destruction of those resources. And then in the middle, you operate the app. So that is more of an application. It also it can go be appropriate for UI processes. So if I wanted to present a modal, there is initialization or initiation of presenting the modal. There is termination of dismissing the modal and getting the result. And there's an operational cycle of allowing the user to interact with the modal. That is mine. Sorry. That was actually a meeting. I was on my meeting I wasn't supposed to be in. It can also be for network processes. So for a session-based network, the initiation is the login, the termination is the logout, and the operational is the API that the session supports. So here's an example of a generic app. It's a generic account app that has to attach to a portal. And this is to describe how scopes actually form hierarchies. So once the app starts up, it probably wants to check for certificates and keys that it has and the environment it's in, and then balk if it doesn't have that. And then it migrates to a scoping state that handles hosting app states, so backgrounding and foregrounding. Then it migrates to a portal connection scope, where it has to discover the portal, it has to initiate a connection and assume it's an encrypted connection and forms an encrypted connection. And these are infrastructure scopes. And then it goes into more application scopes, which actually have views. And it migrates into the network portal session, so it shows up the login view. So there's a view associated with that, whereas the other scopes didn't have that. And then once the user logs in, they can go to the app navigation scopes. So you have hierarchies of app navigations, similar like a lot, but you assign a scope to those and they get separated out. That's me. So scoping is implemented using stacks. So there's a behavior stack and a presentation stack. And for a scope, there is a companion set for behavior and presentation. They get pushed onto the stack, and the behavior actor is the unique behavior for that scope. So it only handles that behavior. And the presentation actor is the basic UI for that scope and only handles that scope. And they interact via requests and events. Okay, so this is reducing complexity into something that's simple. So this is a sequence diagram to give you an idea of how you draw. I did it manually in hand to give you an idea how you would sketch out some of the processes. So this is that generic account app, but I'm starting at hosting scope. So there's various scopes along here. So the first scope is the app starts up and it pushes on the scope for the portal scope. That tries to connect to the portal. And if it's successful, then it pushes on to the next scope, which is the portal scope. That then requests for the session to begin. And then the portal scope presents a login view, allows the user to log in. And if they've logged in, it logs into the portal. And then once that's complete, it pushes into the next application scope or navigational scope, which then tells it to navigate, and you start up all the proper application UI for that app. So this is a way of presenting sequencing of things in BSP. I'm going to leave it there. I'm just going to talk about why you would use it. There is an app associated with this. You can go to the originware.com site anytime. I'll just quickly show you the app before I go. Why would you use BSP? If you've got a complex app, it's certainly going to help you. And you can look at the demonstration code that I've given you there on the demonstration app. It's an Xcode project in Swift 5.6, Swift UI 3. You can file it, you can run it. I'll just show you quickly in a second. All the BSP really does is that it represents behavior in terms of something you just already naturally appreciate and do. You've always been working with interactions your whole life. Socially, you've learned to look at social interactions and physical interactions and sculpture your own. Biologically, your biological system biological systems separated out earlier into, say, 3 levels of hierarchy with neuronal, and then interactional, signaling interactional, and then instructional. Instructional being more the DNA, RNA, construction of proteins, and the interactional being, for example, your nervous system impulses, chemical signaling between various glands, and then there is a reverse signaling as well to form cooperative signaling between those, so that they it's a closed feedback. So nature came up against these design constraints itself, and it chose in a three-tiered system of instructional, interactional, and neuronal. And there in your whole software life, you started with instructional, with code. Things have been progressing to AI, so neuronal, but the missing component has been, which nature has been using for a long time, is interactional. So it's able to handle complex signaling interactions, as opposed to AI and neuronal, which is more cognitive, the decision-making, assessment, that type of thing. So interactional has its own place in that. It's bad for cognition. So with instructional, it's bad for cognition, but instructional is bad for signaling. I'll just quickly show you the demonstration app. It's called the BSP demo app, and I'm not sure this is going to talk. It's got a number of simple commands. You talk to it, it talks back. What is the time? So we're having trouble. We've got a technical problem with our mirroring. It's not showing the sound. So I'm sorry about that. You can search Wikipedia for Project Horizon. You can search for things within Wikipedia. It actually voices to you how it's downloading when it is downloaded. You can message your current location. I'll just dismiss that. What is the location? And you can message your current location. Message my location. It just brings up the message view with
Saint, Sydney, Australia. Please enter the message recipients.
No, I can't talk. Just about to finish. I just send that.
Message sent.
Should show up. Now I'm about to finish. Come on. I don't know, it should do. I'm going to leave it there. So please go to the originware.com site, look at the BSP page, try the app. I'll give you a very good idea of how BSP works for you. It will look very different. It's got a very different shape.
Thanks a lot, Terry. There you go. Do you have any questions?
Yes.
Yeah.
Yes.
So you said that BSP is made to manage complex systems, right? So my question is, how can I know that the app or program or system that I want to make is suitable for this architecture? Is there any guidelines or questions that I can?
Are you having trouble trying to decide how to break it down into pieces?
Okay.
Is it trying to do complex things, intricate things? Do you end up with spaghetti? Do you not know where to start?
Is it something that can like start a project? Because like,
yeah, you can do it at the start.
okay, because those like prompts
you break it into, you work out your services that you want it to perform, you work out the presentation elements, then you work out the scopes. You know, in terms of if you've got navigational UI, you break those down into scopes. If it has to connect to the net, then you break that down to a scope. And then you build up the behavior and the scoping, the stack scopes. So it's an incremental procedure. You don't need to do all that. And also helps you with testing. So you can separately test those actors, and you also can reuse them as well. So you can use them from one app to the other. Yeah. You can always ask me. You can always give me an app idea.
What was the best example that show that this architecture solves problem better than any traditional architectures? I don't know, task example.
Yeah, well, it depends on the person's writing it, but have a look at the app. Have a look at the demo app in the source, originware.com, and it'll give you an idea. You'll get a sense it looks very different to a traditional app. I was going to show you some code segments, but I've run out. A lot of it is just listening to requests and handling those requests. So it ends up being very well partitioned out. And the project structure, look at the project structure. You break it up into models, views, and it looks simple. In previous apps, you'll probably have a very complicated project structure. It ends up being very simple in the project structure. It gives you a sense of where things go, not only behavior, but files as well. And you're going to have confusion at the start because it's not natural for you. You're going to say, I don't know what to do. And that's a very natural part of the confusion, but then it'll become more natural to you after you've used it. So maybe you need a test project to try it on.
A couple of questions. How long has this sort of architecture been around? It's been around for a long time, and
well, it's a specialization of reactive fabric, which is one of the other technologies from Originware. That's been around for about 2 or 3 years. That's a more generalized thing of forming a fabric of interactions. This is specialization of that for UI-based apps.
it's not something, this sort of something's come out of, I guess, Originware or something.
Yeah.
And do you see a lot of native engineer, or should I say app engineers, I guess you've been maybe a few talks starting to adopt this?
This is my first talk.
That's your first talk. Okay, there you go.
I find with reactive fabric, it tends to be very abstract and people may not appreciate what it can do. And that's partly why I formed BSP, which is like a specialization on that, to make it more real for you so you can actually look at the code yourself and get a feel for the benefits.
Okay. So what you've created this sort of architecture from that, is it specifically designed more for, I guess, for an app environment, or also for backend web?
Reactive fabric is for generalized environments, server environments. I've got it running in embedded systems as well as apps, so it's a whole stack. Whereas BSP, again, specialization just for apps, something that has to present. Okay. So it's simplified down to be easier for you for that environment of app development. I mirrored that.
Thanks again, Terry.
More questions? Originware.com.
Of course. The iPad is updating, everyone.
Yeah. That's all right.
I turned my updates
This is
off.
just a cheat sheet.
I turned my updates off, so any good.
That's
Problem is that I don't see the Indian.
there it is. Yeah.
Awesome.
Hey everyone, I'm Balazs. I'm a iOS dev here at Bilue, and I'll be talking about how to bring collection lists to the table, aka using collection views with list configurations to represent lists in your apps instead of table views. First, let's talk about the dry part. So what are the components that we will work with and and to get to know our tools there. So lists had a big facelift, in iOS 14. Wasn't that well announced. I think it wasn't part of the State of the Union, but it was within the talks. Just you had to dig a bit deeper. So basically, what they did is, first of all, they deprecated the title label, and the image view of UITableViewCell, which is a sign that something is happening there, right? So actually, what they did, they introduced a new concept called UI list content configuration, along with UI content configuration and content views. And in the same step, they introduced this to collection views as well. So you can have a bit more customizable configuration to represent view lists even in compositional layouts. So along with other collection view layouts, you can bring in a list easily for a certain section or multiple sections. So actually, these are the elements that we'll talk about, but I will get into the details here. First of all, they introduced the UI collection layout list configuration, which is a compositional layout configuration. And as I said, it can be combined with other configurations as well. And also they provided a couple of default layouts for that, like for example, the iPad sidebar or the insert group, the grouped, or the plain lists. And also they introduced a new collection view cell called UICollectionViewListCell, which is specifically to represent data or display data in a list. Actually, this is like the equivalent of the UITableViewCell. Now, for this cell, they also added two properties that will control the content and the background, the content configuration and the background configuration. The content configuration is the UI list configuration, which conforms to the UI content configuration. And this is all about the content, like text, secondary text, image, paddings between the elements and such things. Also like text properties, image properties, anything that's content related. For the background configuration, they created another object called UI background configuration, which is all about the background. Background color, visual effects, corner radius, stroke, even like actually the tinting is there as well. So these are the two components that we will use with the stock UI collection view list cell to represent data as what we used to do in a UI table view cell. But actually, it's a much more customizable approach, which was usually the downfall of using UI table view cells, that certain things were hard to change, hard to adjust to the designer's requirements. But sometimes UI collection, so the list cell itself and the stock UI list configurations aren't enough. And that's when the UI content configuration comes in. This is a really generic protocol. It is only responsible for actually creating a content view that can be injected into a collection view cell or a table view cell, and also updating it based on the state. And what can you use as a content view? Actually, there is a protocol called UI content view. If you conform to that, the UI kit will be able to inject it into any UI collection view list cell. That's all about the dry part. So now let's see how it works. For that, I need to switch to hearing. Simulator. So here I just set up a really simple collection view in a view controller. I also have a view model with a really simple hard-coded setup. So like we have sections and items. We are generating a snapshot, and we will be using it as a difficult data source. Of course, in the view controller, we have the collection view. We have a data source for it, but that's about it as properties. I used Snapkit to lay out the collection view, really just filling the whole screen. And then when we build the collection view, we are creating the layout configuration as a plain layout configuration. We create the layout with that. Now it's a really simple layout. I didn't combine anything there. And then we just create the collection view. For the data source, as you can see, there is no cell registration for the collection view. Because there's another new thing that was introduced in iOS 14, which is called the UICollectionView.cell registration, which makes it much easier and much more centralized on how to handle our cells. So we are using that for handling the data source changes and the snapshot. There, it's really simple. We just have the cell, and the item identifier, which is actually, let's call it the view model of the cell. We get the default content configuration from the cell, which is actually based on the config that we gave to the layout. And in this simple example, just setting the text from the item and assigning the content configuration, and we have a really simple list, right? As you can see, no data source protocol and no delegates yet. Sorry for that. It's supposed to be on the iPad. The iPad is back. I will just disconnect. Yeah. So as the next step, I added some headers and footers for my collection view. Also updated the view model a bit and the data that it uses. So now we will have 3 sections, and we have a title for the second section, and we have data for the three sections. So as you can see, I also added a cell registration and the footer, a header registration and the footer registration for the data source building. And we can set the supplementary view provider on the data source of the collection view, where based on the element kind, we can use the appropriate registration. And again, those are pretty simple. We are just getting the section identifiers from the data source. Unfortunately, as you can see, compared to the cell registration, which got the item identifier from the data source, the headers and footers doesn't get the sections or section identifiers, so we need to look it up ourselves. And then from those sections, again, we can get the default content configuration from the supplementary view and set those parameters that we need to be set, and then just use the content configuration in the supplementary view. It's the same in the footer. The only difference here that actually should be part of the next commit, but this is how it ended up. So you can also set like directional layout margins on the footer, or actually on any of the views. And this is how you can control the placement of the of your content within the cell. As you can see, the header and footer uses the same UICollectionViewListCell as a base UI element, as a base cell as the cell registration. And also it's important to note that we also need to turn on the supplementary for the header mode and footer mode in the layout. There's another mode that you can use that when you have a cell, an item in the snapshot as in the first place or last place, and it will be handled as a footer or header. But for this example, this was easier to use. And if I run the app, we already have the collection, the list laid out. We have the header on the second section, and we have the footer on the last section. Sorry, I forgot to mention that the footer is only used on the last section. So it's like the table footer view would work. That's a downside of collection view, or not really a downside, just a difference, that there is no such thing as collection footer view. You have to handle the placement of the last footer that you would want to be handled as the collection footer view. Still, it's still pretty simple and it's easy to achieve with the collection view, right? Sorry, with the table view. Now let's look a bit. Oh, yeah, sorry. Let's prettify it a bit and let's switch to a group list, which is actually a super simple difference in there. Instead of using a plain list, we are using an insert group list. And again, as the cells and the supplementary views are using the default, the view provided or cell or supplementary view provided defaults, they are all switching over because we changed the layout. So again, it's only one place that we need to change, and then everything else just follows. All right, our list is forming up. It has a bit nicer appearance, but let's look a bit into the customization. I first run it and then start explaining it. So what I did here is update the appearance of the cells. And all those changes were done within the build cell registration and how we handle the content configuration. So for example, if you want to change the color of the text, so all the properties are within the text properties. If you have a secondary text, a secondary label that you need to fill, there is a secondary text and secondary text properties that works the exact same way as the primary. So I just simply change the color of it. If you need to set an image, we have an image property on the content configuration. And we are just simply setting the image. And if we want to change any of the image properties, we can do it in the image properties. Also, if we want to change the background color, for example, for the cells, we can do it on the other property on the cell, the background configuration. This part comes pre-filled based on the layout. So this particular one is coming as an insert group cell background configuration. So I can directly modify any of the properties there, which is just a color with an alpha. And also, as we saw it before, if you want to change the placement of the content within the cell or header footer, we can do that by the directional layout margins. So all nice and well, we are using a stock UI collection view list cell, but what if we need to use some custom components? The good news is that we don't have to create a new cell subclass, because we can create any view that actually can be reused anywhere else in the app, and we can inject it as a content view. Let's see how can we do that. For that, first of all, we will need content configuration and the custom view that we want to use. So I just created a custom footer file and like stored everything in there. So for the configuration, it doesn't have to do anything with list content configurations. It just has to be a generic UI content configuration. So it has to have a conformance to the UI content configuration, which requires a make content view method and an update for state method. Actually, we didn't do anything with the state, so I left it as it was. And here we just need to create the view that needs to be injected in the cell. Now, the view itself has to conform to UI content view, which basically is just requiring us to have a configuration set in that view. And then on changing the configuration, that's our job to make sure that all the updates are done that we need to be done. Also, it's important to note that we need to call the configure at the end of initialization as well, because we can initialize the view with the configuration and the did set won't trigger. As you can see, the view itself is pretty simple. Just a simple snapkit layout for it. And it's also our responsibility to include all the properties that we want to customize in the content configuration. In this case, it was just the text, the margins, and the font that I wanted to use. And then in the configure method of the view, we are just handling and setting those properties. In the view controller with the registrations, I just changed it in the footer registration, so nothing new there. Sorry, one more important piece of information, that usually the content configurations, the default ones, can be found on UI list content configuration or the UI background configuration. So that's what I did with the custom footer as well. So whenever we want to use that custom footer, I'm just calling the default configuration to get the default configuration and set the properties that I want to change. And once that's done, our footer is a custom footer, which is not a big difference. As you can see, it goes to the edge of the instant grouped cells, which, funny enough, wasn't possible with the stock one. Of course, you can use it for any part of the collection view, for the header, the footer, or the cells themselves. And again, whatever custom view you need, you can do it in this way. Any questions? Yes, please.
Two questions.
Yep.
First one, have you used it in production already?
Yes.
Okay. So second question. What are the benefits of using it over just a list in SwiftUI? Because the target is iOS 14, right? So I can already use like SwiftUI 2.0 or something like that. So what are the benefits of using this layout over just list or VStack in SwiftUI?
First of all, the project didn't start at iOS 14. So the main reason is that the app was written in UIKit.
Okay.
And we didn't start refactoring the whole thing. And we also didn't want to end up with part this, part that.
Okay.
This was easier to implement.
Okay. Have you needed to rewrite the layout? Because I tried to use it and it requires compositional layout, right?
Yes.
Yeah. So have you had existing layout or you needed to rewrite it to compositional layout?
So actually we converted UITableViews as well, but they were already using the default data source. So that part was in place and actually that didn't have to change. But as the creating the layout is 3-4 lines of code, it's not a big difference.
Okay.
Of course, it's part of the story that we are trying to use as close to the defaults as possible. Whenever we can. Obviously, if the business requirement is something else, then we have to build our own custom solutions. But if we can, if it's enough to have 2 labels, an image and an accessory on a row, then we don't want to get away from the stock cells, as they have already built-in accessibility and all the dynamic types and everything is in there. So we want to leverage that.
So you moved from table view, right?
Yeah.
Okay. And why would you need to do that?
Because also in some other parts of the app, we started to use this, and there were some minor differences in the default values.
Okay.
As well.
I think the memory consumption is much better in this one as well, right?
Yeah.
Or did you see any?
Yeah, so the collection view has, it has a better performance.
So obviously for the static set of rows, that's super clear. What about the traditional kind of unknown length or known length but recycling cell very long tables?
It is doing the same thing.
Same thing.
So actually right now, as you saw, the whole snapshot is generated by the view model. And this setup, what I did, can accept any snapshot with any length. That's all handled. So the reuse of the cells and everything, it's all in there. The only thing that I omitted is the async loading of images. And that's not that easy if you are not subclassing your cells. It is possible, of course. There are certain different solutions for that. Also, like on DubDub, Apple had a nice sample code with their asset store that could handle it pretty nicely. And actually, I heard it referred to as one of the first production level code examples that Apple provided. But yeah, so that requires a different approach than what we are used to.
Does this collection views support drags and drops like table views?
With a couple lines of code, yes. Yeah.
I often hear about people always recommending using collection views over table views anyhow, making the cells large or whatever, full screen, all that. I'm assuming this would have the other added benefit of being the UI collection view. And if one day you need to change, instead of just having a single list, maybe having a collection view sort of layout, you could easily just replace that with your collection view layout, and it's much easier to do.
So actually the layout configuration, the list layout configuration works in a way that you can create not only whole layouts with it, but sections in a compositional layout. So that's how the whole customizability comes in and gives you the additional flexibility. Okay. Because if you just need to introduce a new section with 2 cells horizontally, you just move this layout config into a section and create a new section for that.
Okay, cool. Any other questions? Well, thank you. All right, well, thanks for coming. So I'm just conscious that the camera is very zoomed in here, so I'll kind of, anyway, thanks everyone for coming tonight. It's great to be back in person. We'll catch you all next month for the accessibility special. And thanks for coming again. And thanks to everyone watching online. So, bye, have a good month.